Terry, thanks so much for the RAP repeat invitation here. Thanks to each of you for your interest. And when I inaugurated the RAP Talks last year, I spoke about a subject called BIM and technology advancements, which span better project delivery and better asset performance at the same time. The IM in the case of project delivery is through greater breadth of information mobility, and better asset performance through greater depth of information modeling. The thing is, we can advance in both of those directions at once, and we need to do that for reliability. So you might say that we start with CapEx. Your concern is OpEx, but your organization's concern is TODEX. And the opportunity there for all of us is to drive out costs while we improve reliability and safety. And we feel at Bentley a particular responsibility and opportunity to help with that, because our software footprint starts with our microstation engineering applications for design modeling and analytical modeling of the assets you maintain, and then our project-wise environment for construction modeling, project collaboration for integrated projects, but ultimately all the benefit is for the owners in our asset-wise environment, which we'll talk about. But the point is to leverage the digital engineering models across that TODEX lifecycle opportunity. So here's our playbook portfolio of Bentley offerings, which you see span, I think, also the infrastructure assets you're responsible for. In blue are our new offerings in the past year, and much is exciting and new. So our company has grown over 30 years from 5 Bentley brothers to now 3,000 folks throughout the world, and helping your organizations to start with in relation to engineering design tools, where we're number 1 in the world by ARC's reckoning in many of the assets of relevance to you, number 2 overall. But in particular, over the past 5 years, we've invested in particular to become now number 1 in asset reliability software for many of your domains, and number 2 overall. So at our annual Year in Infrastructure conference last month in London, Terry was good enough to host a vital summit by invitation regarding asset performance to talk about new opportunities in TODEX, including for operational analytics, because during the past year we have acquired Amulet for operational analytics, sort of so we go beyond engineering to be able to include the environmental and economic context of operating and maintenance decisions. And so Gartner, which makes recommendations about asset performance management, sort of as a result reckons that the capabilities we ought to be responsible now to bring to you through this TODEX lifecycle would be comparable to the other leader, General Electric. And as we know, they work pretty hard on the industrial Internet of Things. So one familiar name among the many users of Amulet is South Australia Water. We recognize them. Terry mentioned our awards program. In 2009, there was a big drought, and in Adelaide, they designed a new desalination plant so well that the digital engineering model's quality won our award that year. And South Australia Water, over the meantime, has completed that plant. It's come online and has made their operations and maintenance environment more challenging. So they turned out to have won, as a result of the way they responded to that challenge, the Global Water Initiative of the Year award and our award, and let's see how.
In South Australia, SA Water has introduced predictive and real-time operational analytics through Bentley's Amulet software, improving customer service while reducing operating costs.
I think the tools we've developed here are an example of the sorts of things that will be very common in the future in industry, especially industry with large asset bases where you've got complex things to operate. It allows you to take a variety of inputs and make the best possible decision. In our case, we've got some sophisticated optimizers we use that Amulet sits around, and it makes a big difference to the way we organize our network and how effectively we can operate.
So they start with a rolling weather forecast. Everything in their business depends on that. But they leverage the digital engineering models to optimize their electric demand against variable electric tariffs during the day, but end up with a network status capability that improves operations and maintenance and is saving millions of dollars per year there as well. And then they complete that by using the optimized forecast to purchase energy forward to save even more. So you can learn more about that example, which Gartner calls a successful operational intelligence system, from Gartner in this case study. So I'm not going to spend more time on that now. But this notion, what Gartner in particular says here, is the benefits come from integrating operational technologies with information technologies. And we know that in reliability, we start with operating technologies as these, and we work on from the IT side and can help with asset reliability monitoring in that respect. But there's a gap still. And when we talk about digital engineering models in your organizations and around your assets, that includes the work that's been done by engineers in terms of schematics and where there are 3D models. There are functional and parametric components that are part of the engineering catalogs and specifications, the analyses and optioneering, and the network models to put that all together exist or existed in your organizations. Those digital engineering models, it seems to me, are where we can fill that gap and add ET to OT and IT to go beyond asset reliability monitoring to what I'll call asset reliability modeling. And in the industrial Internet of Things, we can apply innovative hardware for computing and sensing and mobility and devices and positioning and so forth, digital imaging, which we'll talk about, from UAVs included. But with that, we have a lot of big data. The actions we need, the decisions we make during operations would be much better served if we understood the operating baseline context from the digital engineering models that do exist. That, I think, would be the key to those benefits. So we might have an asset reliability modeling, of course, 3D models of our assets, and those can be an immersive window to dashboards and failure modes. And then it would be the case across our organization that our alarms and filters across our network, in the case now sticking with the substation and transmission and distribution example, but where in the world and then where in our plants is the problem occurring, and the 3D model in this case is a immersive interface even to get to, as we see here, the failure modes and the recommendations, which of course could include work orders that we generate in various ways as part of the Maximo environment. I know many of you here are part of a Maximo world, and we're glad to be part of that as well. But ultimately, the maintenance takes place in the field, and this winning award this year is for Western Power, the largest power distribution, the largest power company in the UK, which has brought the digital engineering models for their whole network to every member of their maintenance force with iPads in the field and with access to the whole network, and where we work hard to download just the changes, 5,000 per week to each one. And then for the importance of your work, when we put that all together and connect it, and a finalist in our awards last year was the Malaysian Power Company, and when I visited Malaysia this spring, I was given this award, really representing all of the good work done by all of you. That's the CEO of the Malaysian Power Organization, and the appreciation he has for improvement in their reliability and the resulting network performance improvement and quality of life in Malaysia. So there's a lot that's important that we can accomplish by connecting IT, OT, and now ET. But what about all the rest of us? And we might in particular not have our engineering models and digital engineering models accessible. Can we get to asset reliability modeling and those same benefits? So a case in point might be Exelon, and this is a case study from a few years back where they leveraged our technologies to start with health indices for each of their substations and assets and being able to look at their condition across their fleet and some traditional dashboards and so forth, but they're interested in going further, and this year Exelon ComEd became the first utility to get FAA authorization to use UAVs, and how would that help close that gap? Well, the answer is a technology breakthrough that has occurred in the past year, and we have acquired software for what we call reality modeling. Reality modeling is to capture existing conditions, and to do that in ways, the start for that was laser scanning, but laser scanning requires specialized tools and equipment and produces an intractable, noisy, and unintelligent point cloud. Reality modeling produces a reality mesh in the same environment that engineers work and which can be part of your immersive interface in maintenance. And it does so starting with ordinary digital photographs and triangulates from angles using any camera device, including, as you see here, even your smartphone, but especially well suited to capture from UAVs. So here's an actual substation in France, in this case, where, as you see, 286 images from the drone, supplemented by 100 and some from the ground, and of course using GPS coordinates built into the cameras, and producing this 3D model, which is an actual 3D model, a mesh model, down to the level of detail you see here for something that represents the type of brownfield assets that we all need to work on to improve reliability. So we could, through that context capture process, have as operated digital engineering models for all of and any of your assets and survey them continuously, because it requires no special crews, and you probably are already acquiring UAVs to do that. What's different is that the reality model comes directly here into the engineering environment. This is our microstation environment where, for instance, the nameplate can be captured in 3D here and used to set up a link, which we'll call a functional index, to associate it with all the other information associated with that particular transformer in this case, so that it can be navigated from the field through the immersive interface of that as operated 3D model, and that can include the maintenance manual as in this case. But we could go on then, let's take the case of Exelon, where they have failure mode history and catalogs relating to that particular transformer, if you like, and bringing that in and associating it as well. Each time the drones are flown and that substation would be scanned, this information would be connected once you establish these links to those GPS coordinates XYZ, and that would include, for instance, the schematics that could serve to improve reliability in the field. And then our Amulet software can be used to define the alarms and set up filters as here. So to configure alarms and filters particular to this transformer, and this is the example of National Grid and the dashboards they apply to transformers for their performance, but you would then configure it for this particular instance and this particular piece of equipment, and including who's to be informed when alarm conditions are met. And then this notion of alarms and filters, your UAVs can be used as well, in this case, to acquire from a UAV with two imaging devices, a thermographic along with photographic, so that the operating temperatures can be tracked and generate alarms in relation to that 3D model. Well, suppose the alarm was such that something needs to be re-engineered. So here's the Bentley substation design modeling application, where you would start with a catalog, and the catalog knows the failure modes and properties of the new substation components, which is designed in 3D and with 2D schematics, but would be designed in the context of the existing conditions. So this is the environment with the engineered design applied in the context of the existing conditions. And now every time we scan that, the 3D models are found, they know where they belong, and we can start to difference the as-operated conditions from the as-designed conditions because we design in the context. And here, this maintenance assignment might include hardening this substation outside Paris with fortifications and light, for instance. So then finally, and to come home with you here, it only helps when issues are resolved in the field. And your maintenance force uses devices that vary like this and apps. Those are our Bentley app catalog. Your own job involves using these devices all of the time and different devices throughout the day. So our new software generation is called the Connect Edition, puts that all together, connects it through the Azure cloud. We work very closely with Microsoft. So the result is that your maintenance force increasingly are digital natives who would actually find the immersive interface from the 3D model captured here and provided to their environment along with all the functional indexing of the digital engineering information that's been connected and connectable to the field. On the one hand, to improve their jobs in maintenance and operations, and then help engineers, on the one hand, who work in an environment like this, but have the field observations synchronized with them, and they're using a Microsoft Surface Hub device which has exactly the same interface, exactly the same app as our field devices. And the Microsoft Surface Hub ships with the software from Bentley Systems to do this for your maintenance force going forward. So I think it can be put together for all of you. We can get a start on that. It's not possible a year ago. It's something we can get underway with now, connecting OT, IT, and now ET. And that's a wrap for me, except for encouragement. My colleague and our Vice President of Communications, Chris Barron, helped me with this wrap talk to encourage you.
At IMC, you know we're gonna make the world reliable with failure modes and effects analysis that's undeniable. The UAVs are flying and inspecting interactively, reducing operating risk and pairing it proactively. My Internet of Things. Hey, it's so addictive, shows options to me. Hey, it's not restrictive, shows me what to do now. Hey, it's so prescriptive, bridge IT and OT. Hey, and even ET. This is just my rap talk. Hey, produced by Bentley, and we don't need Kanye. Hey, cause we got CB at IMC, you know we're gonna make the world reliable. Bridge IT and OT. Hey, and even ET. At IMC, you know we're